To this point, we have found the probability using the empirical rule. We've found probability to the left and to the right, and now I want to talk about what happens when you're finding the probability between two different values. So again, if we're using between and we're using a z-table, again, I wouldn't recommend using a z-table, but I'm going to show you because this is stats and you should understand what a z-table does. So again, the first thing I'm going to do is draw a picture. I'm trying to find SAT scores that fall between 450 and 600. So that's the shaded region. I can't use the empirical rule because this value is not exactly 1 standard deviation, etc. I can find my z-scores, negative 0.5 and 1, so I found a z-score for each of those values. And then I've used my z-table, which I didn't copy over for you, but I found the percentages based on the z-table. Now, here's the part that I want to stress to you. The probability that z is less than negative 0.5 would be on my little chart would be that 450. It would be this region. The probability that z is less than 1 would, again, on my little table, this is 0, would be from here on over. Now, as you can see, finding those two values, that this part got shaded twice. It got shaded here and it got shaded here. So to find just this region in the middle, I want to take this value and subtract this value. So that is what I've done here, is I've subtracted the probability that z is less than 1 minus the probability that z is less than negative 0.5. And that is my value of 0.5328. So the sentence, of course, would be that the normal model estimates that 53.28% of scores fall between 450 and 600. Again, using a z-table, not my favorite way. Using Excel, again, not my favorite way. Excel makes things a little bit more complicated. I would again have to find the two values, and then I would have to subtract them just as I did on my previous example. Now, using StatCrunch, I can of course compute this, a mean of 0, a standard deviation of 1. I'm actually going to click on between, so 0, standard deviation of 1. I'm saying between negative 0.5 and positive 1, and then compute, and now it's drawn my picture for me and told me that it's 53.28%. Again, I could have done that without the actual z-scores and used the raw data instead, which I did here, mean of 500, standard deviation of 100, and then plug those values in. I'm doing the exact same thing, so I'm going to second and vars, norm CDF. Again, my left-hand side would be my negative 0.5. Make sure you're clicking this negative 0.5. The upper value is the positive 1, and then 0, 1. And it gives me the value that I want. Or just as I've shown you here, instead of negative 0.5 and 1, we use 450 and 600, and then you make sure you turn the mean and the standard deviation into the raw data scores. Here are 3 questions I would like for you to try regarding the normal model. So press pause, try all 3 of these questions. You can use StatCrunch or Excel or your TI-84, it doesn't matter to me. I'm going to show you on the TI-84. But do all 3 of these and then press play to check your work. So this one is talking about the fuel efficiency of cars, and the mean is 24 miles per gallon and a standard deviation of 6 miles per gallon. So if I'm trying to find the percentage of all cars less than 15 miles per gallon, then I'm looking picture-wise, because we know we like our pictures. I'm looking at the 15 being to the left of 24, so really I'm looking for this region. So in my head I'm thinking, well, it's going to be less than 50%, obviously, because it's less than half that is shaded. So I'm going to do my norm CDF, negative 1,000, comma 15, comma 24, comma 6, because the mean is 24 and the standard deviation is 6. Or I'm going to use StatCrunch to do the same, and I'm going to end up at 6.68%. The percent of cars between 20 and 30 miles per gallon, again, if I'm using my norm, that should be norm CDF. Norm CDF would be left hand of 20, right hand of 30, mean standard deviation. And then more than 40 miles per gallon, left hand of 40, right hand of 10,000, because that's what I usually use. I probably use that up here too. Comma 24, comma 6, and then I get a very, very small percentage. So it's not very likely that a car is going to get more than 40 miles per gallon.